Hello. In this video tutorial, I'm going to talk about different scan settings and their relationships to each other and to other elements such as file size. So let's go ahead and we'll begin. Alright, so let's first take a look at the relationship of scan area and how it affects different items. And what I mean by scan area is the area of what we're scanning. So if this represents my object that I'm scanning, maybe I'm only going to be scanning a portion of that image. So maybe I'm scanning that much of the image. That is going to determine in part the file size. So if I take and increase my scan area, one of the things that's going to affect is the file size. What that will do is if I now take and change my scan area to something that is larger, I now have more pixels that are going to need to be stored. My resolution has stayed the same. All my other scan settings have stayed the same. The only thing I'm changing is my scan area. So if I am increasing the number of inches horizontally and or vertically, my resolution is based on so many samples per inch. I'm now going to have more samples overall, and that needs to be stored. So I'm going to be increasing my file size. So as the scan area increases, the file size will increase. All right, let's take a look at another one. Let's look at the effect that resolution has on scanning. Remember that resolution is the number of samples per inch. So we might have numbers anywhere, it could be very low, maybe we have 60, we could have 100, we could have very, very high numbers, maybe up to 4,000 or even higher samples per inch. So that means when our scanner is scanning our image, it is the number of samples that it is gathering for every inch of my copy. So if I am increasing my resolution, I am increasing the number of samples per inch. Therefore, in regards to file size, there will be more data to store, and we're assuming everything else is the same. The only thing we're changing is resolution. So we will have a greater file size. Let me further explain that. So if I have an image, maybe this represents a photograph that I'm going to be scanning, and within that image I'm not going to scan the entire thing. Maybe I'm going to scan only a portion of it, and let's say that portion. And the first time I go to scan this, we'll say that I'm scanning it at 100 samples per inch. That means for every inch going across, every inch going down, we have 100 samples per inch. Without changing my scan area, well, let's make this even simpler to understand. Let's say this is a 1 inch by 1 inch. So I would have 100 samples by 100 samples. So what I would end up with then there is 10,000 pixels worth. I'd have 10,000 samples because 100 times 100 is going to be 10,000. If I were now to change this to, let's make it 1,000 samples, let me squeeze that in, 1,000 samples per inch. I'm now for every inch having 1,000 samples, every inch vertically 1,000 samples. Now I have 1,000 times 1,000, and now what I end up with is 1,000,000 samples. Same scan area, but now I have more data to store. I've got, instead of 10,000, I've got 1,000,000 samples. So my file size is also going to increase. Also, to a certain extent, it's going to depend upon what we're scanning. The amount of detail that we're going to capture is also going to increase as we increase our resolution. And I say to a certain point. That's going to depend upon our original, our copy. Certain types of copy are going to be limited as to how much detail you're going to be able to extract from those. For example, if you have a color print, you have some photograph that you've had duplicated at a store. They printed it on print paper, photographic print paper. And if you now go to scan that, so you can have a digital copy of it, typically you're going to find that those are going to max out around 240 dots per inch. The amount of detail that's in that photograph is around 240. If we were to scan it at a resolution higher than 240, our file size will increase, but the amount of detail that we're going to get out of that image is at that point going to remain the same. So if I were to scan this photograph at 1,000 samples per inch, it is simply making the file size bigger. I would want to limit my resolution in that case to around 240. If you want to be a little bit more on a conservative side, even around 300 dots per inch, setting our scanner to 300 samples per inch. I'm using dots because I'm representing here the photograph having a certain amount of detail, that detail in the grain of that particular film, and those being represented by dots, whereas the scanner setting is technically samples per inch. Other kinds of copy may be very, very appropriate to have it at some higher setting. For example, if you are scanning film, and by film I mean negatives, negatives do have a tremendous amount of detail. They are intended to be enlarged. So you can scan those maybe as high as 3,000 samples per inch in order to maximize the amount of detail that's going to be in your scan. So you have to look at the kind of copy that you're going to be scanning as to what the maximum you're going to be able to scan that at without simply making the file size bigger and not gaining any additional detail in that scanned image. All right, let's take a look at another one. Let's take a look at bit depth. You can think of bit depth as the number of colors that the system can represent. And it's going to be represented by bits. A bit is either a 1 or a 0. So if we use a single bit, that single bit can be either 1 or 0. We have a total of 2 colors that we can use. And that's going to be black and white. So if we are doing line art, or we have maybe something we've drawn, we've used blue ink on white paper, but we want this to be scanned as black on white, we would use 1 bit. We could scan it at a higher setting. Your scanner may go up to 48 bits, which can represent millions of colors. I don't recall the exact number. What's going to happen as the bit depth increases, the number of colors that it can represent is increasing, and if everything else stays the same when we go to scan, our file size will also be increasing. So if all we have is something that's black and white and we're going to scan it, but we scan it instead at 48-bit setting, our file would be 48 times larger than what it would need to be. Not very good for scanning. We don't want to make things excessively large when we don't have to. We could always take that 48-bit image and downsample it to something to 1 bit, but better to do it correct the first time. There are other kinds of settings. There may be on your scanner 8-bit. With 8 bits we have 256, and typically there we're looking at shades of gray. You may have, again, it depends on your scanner, you may have a 16, you may have a 24, you may have a 32, and as each of these go up, we're looking at an increase in the number of colors. And these at this point typically now are more than just gray. These are tens of thousands, millions of different colors and shades. So you can think of these as the number of crayons in your box, the number of colors that the scanner has to work with. You can scan something that has all kinds of color, and if you scan it at 1 bit, it needs to convert every single thing there to either a black or a white. You could scan something that is a color image and scan it as 8-bit. It would then convert that to shades of gray. But once again, as we increase the bit depth, we increase the number of colors. We also increase the file size. All right. That's the discussion there then of how these different things correspond to each other. As we change one, how it affects other elements.